Next speaker is Dr. Seifu Bekele. He is a principal wind engineer of the HVAC engineers and scientists in Australia. His topic is contribution of the surrounding on natural ventilation of the buildings.
Thank you for the introduction. Good afternoon, everyone. Well, as you know that the sustainability of building design, the reduction of energy consumption in building is the big topic for designers these days. And one of the topic on this is the contribution of natural ventilation in high-rise towers. So we picked one part of it, that is what is the effects of the surroundings on natural ventilation. Well, I will have a brief introduction about natural ventilation, and then I'll go through the effects of surroundings on natural ventilation. One of the important parts of when you consider natural ventilation is the climate. What is the contribution, and how do we have to look at the climate? And the different components what we used for this study is a wind tunnel study and computational fluid dynamics we used. And I'll discuss the results and we'll have summary. Well, why is natural ventilation? What is the motivation to have a natural ventilation? It can be, to fulfill a building permit requirement. In some parts of the world, the building permits requires, you have to fulfill, especially for residential buildings, a certain part of, a certain areas, or 60% of it is naturally ventilated. That can be, a motivation to use, natural ventilation. Or it can be a part of a sustainable design. Also, the high cost of HVAC system can be a motivation to use natural ventilation. Pollution associated with HVAC system. What we wanted is, to reduce, the carbon footprint of the building. And how can we do it? To reduce the carbon footprint, we use, the material what we are using for the building can be, but also, the natural ventilation is one part of it. When we are talking about natural ventilation, it's not something new. It is essentially a part of life for animals and humans. When you are, looking, historically, it has been used, natural ventilation in history. Say some of it, which I have listed here, is in the Middle East, wind towers. They catch a wind at upper level and diverted it into the internal space so they can ventilate themselves. And this has been, used for many years, but after, a while, because of, say, in the Middle East, they used, when they use, this, yeah, all right. When they use, the wind tower, they understand, what is the climate it looks like. We have studied, the wind tower in Dubai. And when we studied, the historically, how is it oriented? It shows that how they understand that it's all turned to northwest. So they have been using that. And also, I looked at, say, in the 16th century in England, they introduced, high ceilings and big windows to have, a natural ventilation. So natural ventilation is not something new, but having HVAC system, the trend changed, and everyone wants to have, comfort defined just by one single number. And if you go to Dubai, and if you enter to a hotel, it's too cold. You have to have a jacket, People, they are not, they lost, adaptive comfort. So, but now, the cost of energy and other, consideration brought it back to the picture. Well, when we are thinking natural ventilation in the context of high-rise towers, what is the motivation? We know that the population in the world is increasing, the density is increasing. So there is a high demand for having high-rise towers. And having high-rise towers is also has to be more efficient, less cost. Then how can we achieve? So for that, natural ventilation comes into picture. Professor Samuel, he mentioned that when we go upper and upper in height, the wind speed is increasing. That means the wind power is there, but it is a blessing as well as a curse. A blessing because it's a wind available there, you can use it. It's a curse that if you open some space, it can get to the internal space and it can damage. So, but in here, availability of the wind is something which we can use it for natural ventilation. And by doing that, we reduce the energy consumption. What are the difficulties? Controlling the wind with height, that means it can produce the damage, which I said, and it can be when we open, some to admit the outside air to the inside, we can also open space that is the noise from outside, it can get in. In the first session, there was a question which said, oh, well, when you open something, there will be, actually the question is based on stack effect. It will be a stack effect on the lift noise will be produced. Actually, yes, so stack effect as well as, a wind-driven can produce, those kind of, a whistling noise. But there are, ways to get around that. That means, why that kind of noise is generated? Because of the pressure difference, there is, a flow is driven. So you have to equalize, the pressure, between the inside and the outside. You can achieve that by even drilling the hole, by diverting, the wind from getting to the lift to another direction. We have come up, this kind of problem in existing buildings. And there are, different ways of treating them. When we are thinking, natural ventilation, especially for residential buildings, we are communicating, the air from one space to the other. That means the odor from one apartment can go to another. That can be, a problem. Also, a fire regulation requirement. That means during fire, the stairs has to be in a higher pressure than the other space. That means the smoke won't get to the stairs. But if you open somewhere, then the wind can be higher and get in, and maybe higher than the stair, and the smoke will get into the stair. So that is, a challenge. But this challenge can be eliminated by implementing different technologies. Dependability is another problem with natural ventilation. That means, when we have to use it, when we don't have to use it, we have to know. At first, when I started, I said that the availability of energy can be a curse. That means if someone living in a high-rise towers leave the window open, that means the internal pressure of the building increased. That means it causes a lot of damage. And when we are doing the study, one of the considerations is that, well, to eliminate that kind of problems, there are a lot of solutions. One is the building management system or installing a control. The other thing is Robert, he mentioned about, comfort. One of what we use, natural ventilation is to achieve comfort, thermal comfort. And that thermal comfort is something subjective. And how are we going to have that subjective things to fulfill? You can design something natural ventilation and people say, oh, it's not comfortable. So it needs people also to accept, to expand their limitation. I lived for many years in Canada, Alberta. It is very cold. At 5 degrees centigrade, I used to go out without a jacket. But when I moved to Australia, well, I have to put, at 5 degrees centigrade. So to the area, I adapted, to the situations. But if people are saying, no, my comfort is when it's 18 degrees centigrade, it's very difficult to fulfill that. Understanding the physics of ventilation is important. The two main ways of ventilation is buoyancy-driven. The buoyancy-driven means there is a pressure difference, there is a density difference caused by the temperature difference, then there will be, air movement from the cold region from the cold zone to the hot zone. The other one is wind-driven. So the wind drives from one high pressure to the lower pressure side. When we are looking at these two, the buoyancy-driven and the wind-driven, they are in a different scale. The one which is the wind-driven is in a higher, because of the pressure difference is high. What are the influencing factors for natural ventilation? Climate is an important part which needs consideration. External geometry of the building is an important part because we get ventilation because of the difference in pressure. By changing the shape of the building, you can produce a positive and a negative pressure. That means you can dictate, where is the inlet and where is the outlet, by understanding also with the climate. Once you have, the air to the inside, then how it is going to move inside, whether it's going to dissipate, the internal partition plays a big role. Looking at in the big scale that in the town planning, the road orientation, and the mass distribution where you have high-rise towers also plays a big role. When we have the natural ventilation or the ventilation system, we may have different objectives. The objective is just to achieve thermal comfort or to reduce pollution, it can be. That means a concentration in there are some dead spots, and especially when we are looking the external environment, we are looking, to eliminate the zones. When we are studying, the external environment in a hot area like Singapore or Malaysia, what we are looking is where is the dead spots are. Where is that means the higher pollution concentration, and we want to eliminate that one. Possibly that is not our main concern if I'm going to do the study in Canada, because the air movement is in a cold environment is very sensitive. Well, when we are talking about the surroundings, there are different kind of surroundings. One is it can be like a waterfront. That means a waterfront means no obstruction at all, which we can see that buildings in the waterfront, they have no obstruction. Or it can be a suburban, which is a suburban buildings with some obstruction. It's not a lot of obstruction. Or it can be a city surroundings with a lot of obstructions. The height distribution of the towers plays a big role. That means if there is a stage, if this one is the most frequent in direction, then I know that the wind will be available in different locations. But if the wind is this direction, then I'm blocking it. So that the height distribution plays a big role. the spacing between buildings has a big role. If there is a good spacing, then I know that this building is going to get. But if they are very close apart, then the wind flow over it. So I'm not getting, I mean, a lot of wind at the bottom. The orientation of the road relative to the most frequent wind is important. That means, as I said, if I have, I mean, a wind which is coming from the sea, and if I have a wall of towers in here, then I'm blocking it, the wind from here. And the opening of the road shape, how it's oriented, it plays a big role. That is what I mean, that the town planning have a big part to play. Well, in the study, in the present study, which we used a climate model, and we used a wind tunnel study, and we used computational fluid dynamics, I mean, to investigate what is the effect of the surroundings on on achieving natural ventilation. Well, when we are talking about the climate, the important components of the climate which we are looking is temperature, humidity, wind speed and direction, and the variation of the climate with time, daily, monthly, how does it look like? That is important, I mean, to decide where is my openings is going to be. The variation of climate with direction is important. So these are the main things which we have to consider. And then, based on this information, we decided, okay, I can have, I mean, natural ventilation for this month, and I can't have it for this month. I may have to use, I mean, some kind of treatment. This study, which what we have done is we pick one of our project, one building, and then we placed it in different locations of Melbourne, okay, in a city surroundings, in open area, and to see the effect. So when I am presenting, I mean, here is the climate, what we are looking is, wow, all right. The climate, what we are using is the Melbourne climate. This is a psychometric chart. It is good, I mean, to understand. It has, I mean, the information, the temperature, the humidity, and the speed, but it is colored based on here, based on wind direction. When I'm looking the the June data in Melbourne, it's cold. So all the data, what I have is here. It's very difficult. If I admit this air to the internal space, it will be a problem. So I can't simply use, I mean, natural ventilation. I have to treat this one. Well, if I look, I mean, the December data and colored it, this is based on direction, it's colored, and it's a lot of hot days, and that hot is coming from the north, because this is 0, and the colder comes from the south. So it tells me the directionality, but for this, if I admit it directly to the internal space, it will be a problem. When I'm looking, I mean, the March data, well, most of it is, I mean, a good one, which I can admit to the internal space. What kind of treatment I have to use? The psychometric chart, we can divide it, and we can learn that if it's humid, what kind of treatment we have to use. If it's cold, what kind of treatment. So it is a very good tool. This one, it's colored by the time of the day. That means in the morning, it's very cold, and in the evening, it's hot. The same data, if it's colored by directionality, it shows that coming from the south is colder, and coming from the north is warmer. This is the Melbourne data. The south is from the water, and the north is from the land. Okay, what we used is 3 cases. This is, I mean, a CT, 1, 2 CT cases. And this is a suburban case. This is an open. These are the 4 cases we used. And in the CFD, we used, the CT case. And this is an open one. And when we see, the pressure at different locations, this is observed at this point, we see that the CT1 is lower pressure, and the open one is higher pressure. And at different points, I'm seeing that it's moving from the southwest when I'm observing it at this point. And I'm observing at this point, it's moving. And now at the north, it's moving. And in here, you see that the CT case, the 2 CT cases, even though the wind is coming from this direction, the main high pressure is from this direction, and for the other one, this direction. So the directionality plays a big role. And in here also, even though the wind is coming from the east direction, this remains from the other direction. When we are looking, the CFD, this one is for the CT case. It shows, a lot of turbulence. For the open one, it doesn't show, a lot of turbulence. When we are looking the internal space, this is, a 2-bedroom one. There is, a lot of circulation because of having, 2 openings. A 1-bedroom, just it is because of a single opening. It has a minimum flow. This is a single building, which you see that there is a lot of circulations in a 2-bedroom. Oh, this is by mistake, actually. This is 2-bedroom one. This is a single bedroom, which has, less. So in conclusion, what I can say is the external structure, which I have, I run it, so fast that the 2 cases which we simulated is one is open, one is suburban. It's almost open. So the 2 cases are almost similar. That tells us that whatever, if you are considering, at the top floor, whatever is happening here, it doesn't have, a big influence for what you are doing here. The apartment with more than 1 opening shows, a good circulation. A single bedroom with 1 opening shows in a city environment marginally a better circulation than with open. The only explanation which I can think of is that when you are in a city environment, there is a lot of turbulence. And even though you have 1 opening, there is a fluctuations. That is the one which can have, a marginal difference. The direction of high pressure in a built-up environment is not aligned with the approaching wind direction, so that what it tells us that, well, I understand the wind directionality, and I can design where is the opening is going to be and where I'm going to admit and exhaust the airflow. We can't say that in a complex environment. The physics defines complex flow by 2 things. One is with Reynolds number. Higher Reynolds number comes to a complex flow. The other one is with the structure. If you have a lot of structures, you form, a complex flow. So in a city environment, it's a complex flow. So it is not uneasy to determine. Thank you.
Is there any questions?